An abridged history of light.
In addition to Sir Isaac Newton basically inventing mechanics, dynamics, kinematics, and also coming up with calculus, he did a great deal of work on light. In 1704, he published a text called Optics, and he described light as a group of tiny particles that he called corpuscles. However, certain properties of light, such as diffraction, which is the bending of light around objects, was better described by thinking of light as a wave. So right away you can see we have this particle view of light and wave. The wave theory is credited to Christian Huygens, with work done by Robert Hooke, Leonard Euler, and many other people. In 1803, a century later, Thomas Young's double slit experiment, one of the most famous experiments in physics, definitively proved, at least for the time, that light acted as a wave. Then James Clerk Maxwell published his 4 equations of electromagnetism in 1861. He also treated light as a wave. And then came relativity and quantum mechanics. The first dispute with the wave nature of light came in 1900. Max Planck was working on blackbody radiation, where basically every object emits and absorbs electromagnetic radiation. And the theoretical predictions of what a black body would do, and that's basically a perfect emitter and a perfect absorber, the theoretical calculations did not match what was actually happening. The only way Max could get it to work was to assume that light came in bits of energy, quantized bits of energy like a particle. Then in 1905, Albert Einstein published a paper on the photoelectric effect, and that's the one that he earned his Nobel Prize for, not relativity. That also confirmed that light came in discrete packets of energy. A name for this was given by Gilbert in 1926, Gilbert Lewis. They were called photons. So we've basically come full circle. Classical physics had very happily settled on light being a wave. Before that, you had Newton, who said it was a particle, and now quantum physics is bringing back Newton's idea that light is a particle. The final word, at least for now, comes with the correct use of relativity and quantum theory, especially the bit that describes the interaction of electrons with photons. This branch of physics has a cool name, quantum electrodynamics, and in 1965, Tominaga, Schwinger, and Feynman received the Nobel Prize for this work. Here are Feynman's words on light from his book, QED, The Strange Theory of Light and Matter. I want to emphasize that light comes in this form, particles. It is very important to know that light behaves like particles, especially for those of you who have gone to school where you were probably told something about light behaving like waves. I'm telling you the way it does behave, like particles. You should have a feel now for how light has been the subject of much experimentation and dispute. Even now, people talk about the wave-particle duality of light, and as you go on in physics, especially AP, you will see a similar behavior with electrons, where electrons, which we clearly think of as particles, have wave-like behavior. A good way to rationalize this is that the actual world we observe, with our senses, instruments, measurement tools, is way more complex, and it's really difficult for us to explain what is really going on. But for now, we'll start with Newton and his corpuscle theory of light, light as a particle, and see how it explains refraction and reflection of light.